Hey guys, on do.
Doing fine, sir.
Good. Is it raining by you?
Yes, sir.
Aye, aye, aye. All the rest of you is just the mile on the boat?
So there, sir, in a rain. Be a rain.
Sure
Uh,
there, sir.
trust me. You guys went out to work today, or you stayed home?
Sir, we
Oh,
stay home.
Working.
somebody said working. Taxi, get that work?
Just actually reach home, sir, from work.
Whoa, whoa, osh. Aye. Anyhow, I am just happy. But before I say I'm happy, everybody all right? On a dry and everything good, you know?
So far, sir, yes.
I guess so.
Can't complain.
Yeah, good. Okay, three more joined. All right, mm, we are at a point now where we need to move on. At a point where I need to decide where I'm going to be moving on to. And based on what I'm looking at, I have a tiny reminder of where I am. So we started differentiation, looking at the different rules. We went through first principles. We went through that was that. Then we went through the chain rule. Then we looked at the power rule. Then we went through the product rule. And then we also looked at the quotient rule. So having gone through those rules, what is left for us to do for tonight's class really is just practice those rules. Make sure that we master them. So we can move on to different applications. So what I'm going to do is to share the screen, because today is really, as I said, it's just for you to do the Are you seeing my screen, by the way?
Yes, sir. See you.
Yes, sir, seen it.
Okay. I thought something went wrong with my internet just now. All right, good. So remember, what rule do we use for that one?
Power rule, sir.
No, think about it.
Chain rule, sir.
Look at the function. Read the function for me.
Product rule, sir.
It has to be the product rule, because remember, something is being multiplied by something. So you have 4x cubed being multiplied by x cubed minus 3. Say yes or no.
Yes.
Yes, sir. Sir, but
So
wouldn't this the power rule also be applicable then?
by Raj?
Because we have indices inside it.
When does a power rule becomes applicable, Raj? Can I use a power rule for x cubed minus 3 at all? And you can talk to me now, is that right or wrong? I mean, we're still learning the topic. And it goes for anybody. Am I allowed to use a power rule for x cubed minus 3? Hello?
I'm not seeing a reason why we wouldn't, sir.
Mm-hmm.
Or sorry, is it because the index is equal to 1?
You hear that, Raj?
No, say it again.
Oh, I'm thinking it's because the index, all right, so the rule says in order to use the power rule, the index must not be equal to 1.
Okay, okay, I see, I see.
Right. So you see now I have x cubed minus 3 raised to the first power, but the one is invisible. Can you see that?
Yes, sir.
Mm-hmm. So if I had x cubed minus 3 raised to the second power, or the minus first power, I could use a power rule. But I can't use a power rule when it is exactly 1. And I'm going to explain that a little bit more sometime later.
Then what about the 4x to the third, sir?
For x to the third, when we use a power rule, we talk about something with parentheses. Power rule is when we have the power rule is once you see brackets, raised to a power rule. Once you see 4x cubed, that can be differentiated as is. That's not the power rule. 4x cubed is what kind of rule, by the way? If you say 4x cubed by itself, what rule do you use for that?
Chain rule.
The chain rule. Very good. You use a chain rule for that. So the power rule is when you have, and it's not only 2 terms in it. So it's not, I mean, I could use a power rule if I had x cubed minus x squared plus x minus 1, all raised to the second power. That's a power rule. So I don't only have 2 terms in the parentheses, but we never have parentheses raised to a power other than 1. Consider, first thing you need to think of is the power rule. So in this case, we're going to be using the product rule because 4x cubed is being multiplied by x cubed minus 3. Okay?
Yes, sir.
Right. No, students, let me tell you a secret. You see, this weather, it is a perfect setting for me to drop asleep. So you see, when it's like a night like tonight, we're gonna have to keep the teacher alert because you can't call sir, and sir gone. Cut a rain, nice weather. So I know it's the same thing for you as well. But I'm going to ask you to just be alert and just work with me. I answer the question then. You answer me so that we can accomplish something for tonight. Please and thanks. All right, I give you 3 minutes to work through that question for me. And as soon as you're finished, let me know. I bet you no drop asleep. I bet you no. Hello?
No, sir. The only thing where me kinda confused about is the simplification of it. I don't know which way to simplify it.
Okay. Okay. All right. All right. So what I don't want you to do is I don't want you to be expanding out anything.
Oh, so
When
let's
you
leave it.
yeah, when you do it, try leave it as in the format that they gave you in. With a product with the parentheses.
Uh-huh.
Right. How many of you have gotten to a point of simplification? Okay. TK, I think it's just you and I alone. Are we?
I don't know, sir. No,
No man.
sir, Halloween.
So I think we figure out the one that is second, well, the second part in the parentheses,
Mm-hmm.
and then we're trying to figure out work out the product rule first. Well, for the four cube, that try to figure out the breakdown for that first, and then work the product rule after that, sir.
All right, Lecano, do me a favor. Tell me the differentiation of it. Don't give me the
For the
simplification part as yet. Just tell me what the differentiation is. Tell me now.
for the second part, sir.
The differentiation. Tell me what you get for the
In the-
differentiation.
If you want in the second part, in the parentheses, I got 6, sir.
Say what?
I don't know if I do something wrong, but
Yeah, I think it is something
6,
wrong.
6 make it.
Richard, let me hear what you have for the first line.
All right, sir. 1 second. That number here beginner, sir.
Hmm?
These numbers are very large.
I wonder what it is that you guys doing. Tell me what you have for the first line, because I don't know where to get large numbers from. But go
Start
ahead.
them on.
All right. This is before me put it back in the parentheses. Me have 120x to the power of 4 minus 72x.
All right, okay. All right, don't go no further. Because me no know if a true rain or fall and your avenue block and you have to go another road round there so and jump to patrol. Me don't know when I go.
Look at them, sir.
Yeah, please do.
So I have for first I have 4x cube in a bracket, then you have 3x square plus 1x
Oh,
cube
that made
minus
it.
Continue, Taxo.
all right, I'm go again. So 4x cube, then in bracket you have 3x square, then you have plus the second, which is 1x cube minus 3. Then in bracket we have 12x square.
This one like you live at Portmore. No flooding don't take up no flooding take place in Portmore. That's correct, son. We don't know where the other one them. The other one them live river run at the back
I
of them
didn't
yard
know
and
what
river
the
come
first
to
step
them.
you wanted.
You have that?
And so the 4x cubed, then in parentheses 3x squared plus the x cubed minus 3 times the 12x squared. That's the one you just said?
Yeah, but oh, you get 120 though. Tell me how you get 120.
Because then I add the like terms. So when when I then did the regular chain rule on it, sorry, when I did the multiplication to multiply the 4x cubed by the 3x squared, I got 12x to the power of 5. And then when I did the same thing to the x cubed times the 12x squared, I got another 12x plus 5. And then 3 times the 12x squared is 36x squared. So then I got a total of 24x to the power of 5 minus 36x squared. So then me didn't think say I had to then apply the chain rule to that to do the multiplication.
If I knock you out to CTK, because where I never asked you for the second derivative. I asked to find the derivative, the first derivative. So
Okay.
you do the question and then you go do the question again.
Okay, so it's supposed to be either 12x times 2x to the power of 4 minus 3x, or
2x to the power of 3, not 4. Remember, you
no,
know, you can also factor out x squared, you know. Yo,
This is what I do wrong, sir.
no, you do wrong.
But the abbreviation, sir, that's why we get 6.
We do, you
sir,
do what?
explain back the x cube again, sir.
Soon come to you, Papa. Where is the car now?
I work out the one at the bracket. We use a chain rule for work out the one at the bracket. And that's how we get 6.
Oh, you said 2, 3, 6x. That you get?
Yes, sir.
No.
We forgot to I'm not supposed to work it out.
Smoking is not good. Let alone you go smoke marijuana. The papa will catch you, no. That's illegal. All right, coming to you, TKL. Buff. What to the rest of one? Hey, the rest of one. Dujan, wake up.
Sir, I'd send you a private message.
Sir, looking at chat, sir. You talk about wake up.
Wake up, man. It's in the chat. Oh, you sent something in that chat? But Dujan, a piece of something that means they are sleeping through then, because
You know, that's
piece of
the
person.
ask, so you asked for the first line, and that was my first line.
The first line is 4x cubed times 3x squared plus 3x cubed minus 3 times 12x squared. I did ask you the differentiation. Rayton, I see what you are.
Sir, you said some, okay.
Trying to do.
Oh, then.
But the power something Rayton kind of one little oxtail gravy. All right, let's go through it.
Wait, so how you get the x
Watch me.
cube disappear?
Watch me. Come, watch me. All of your eyes open.
And I made one simple mistake.
And that can throw you off totally.
Definitely, because my answer would have come down to 16x 16x to the 5th power minus the 36x squared, because where
Added something.
in the parentheses, yeah, I did not, when I was differentiating, I did not put the 3x, so I would have gotten 3x squared. So that's where I did wrong, but I get the concept.
All right. Chrissy, wake up. All right, let's go.
Okay. May I see it now, sir?
All right, let's go. So we recognize it's a power rule because we have 4x cubed times x cubed minus 3. You notice I'm calling this my first and I'm calling this my second. Hold on, sir. Could I have not called this the first and this one the second? Yeah. But me no want to twist up my item. I go chaos if we do that. So we just put the one the first. It can be done, you know. Whichever one you want to call the first, it's fine. But I've chosen 4x cubed to be my first. Now, to do the product rule, remember, it's the first times the differentiation of the second plus the second times the differentiation of the first. So Dijon, when I ask you for the first line for the differentiation, that's what I want you to apply. The first times the differentiation of the second plus the second times the differentiation of the first. So the line in blue ends the differentiation. If I see that alone, and it's a 5 marker, you're gone 2 marks already, because that is an application of the differentiation process. What is left in blue and red, in black and red, is just algebra. So let's go. The first, 4x cubed, I call it, I write it back, 4x cubed, times the differentiation of the second, I'm going to differentiate the second. It's not a power rule because the power here is raised to the first. If it had risen to something else other than 1, then it would have been the application of the power rule. So what I'm going to do is say differentiate on the inside alone. When I differentiate x cubed, I'm going to get 3x squared. When I differentiate negative 3, I get 0 because it's a constant, so it's going to be just 3x squared. See here, so 3x squared. So that's the first time the differentiation of the second. Plus the second, x cubed minus 3, see here, so boom. Times now the differentiation of the first, which is 4x cubed. So I'm going to have 3 times 4 is 12x squared, which is this. The differentiation ends here. So one of the things that I want you to do is, and I want you to listen to me, the first, boom, write it back. Times the differentiation of the second, it means that I need to differentiate this. Differentiate, I'm going to get 3x squared, boom. Plus the second, plus, I call it, I write it back. Times the differentiation of the first. Then I differentiate the first. 3 times 4 is 12, 12x cubed, 12x squared. And once it is that you've done that, you recite your little story and do the differentiation at the same time, you're good to go. You shouldn't get it wrong, period. Now, as calculus 2 students, I expect that your algebra is supposed to be all the way up there. So BOMDAS says, I must work out my brackets first. BOMDAS says I must work out my brackets first. Let me ask you. Let me not ask you, because it may confuse you. So I'm going to work out my brackets first. There's another way I could do this, but I am going to be sticking to this method I'm going to go through with you now, because I don't think you're fully mature just yet, mathematically that is. 4x cubed times 3x squared is 4 times 3 is 12, and x cubed times x squared is going to be equal to x to the 5th. See, I give you a recall here. The recall says once I'm multiplying and the bases are the same, 8 and a, I'm going to be adding my powers. M, n becomes m plus n. So because the x cubed and the x squared are the same bases, I'm going to multiply, go by the x, and add 3 plus 2, I'm going to get 5. So what is going to happen is going to be 4 times 3 is 12, and that is going to give me 12x to the 5th power, which is here. Then I'm going to move on to the same thing, same recall. X cubed times 12x to the 2nd power is going to be 12x to the 5th power. See it right here, so? And then minus 3 times 12x to the 2nd power is going to simply be negative 36x to the 2nd power. So I would have simplified my function here, right? The notation says when you're multiplying and the bases are the same, add the powers, or the exponents, or the indices. Now, Richie says, because these two terms are similar, and I agree, how did he know that they are similar? Is it because of the 12 and the 12 they are similar?
No, sir, the power, x to the 5th power.
X to the 5th power, that tells you the similarities. So x to the 5th power tells me that, yo, the two of them are of the same family. In this case, they are twins. In this case, they are twins. Because the coefficient and the power, the term of the power, are exactly the same. So 12x to the 5th plus 12x to the 5th, 12 plus 12 is 24. So it's going to be 24x to the 5th. You notice that I'm not adding the powers. I'm not adding the powers. I recognize that x to the 5th and x to the 5th are the same, and I'm adding, so I'm just going to put back the x to the 5th. I'm adding 3 American apples with 3 American apples. It means that I have 6 American apples, don't it? True or false?
True.
Good. So the American apples term would be the x to the 5th. So I'm going to end up with 24x to the 5th. I'm not multiplying the x to the 5th and the x to the 5th. And then now the 36x squared is a term by itself. Now, so what is going to happen is I'm going to have 24x to the 5th minus 36x squared. One of the things you'll notice with me is normally when I'm teaching online and I'm using my typed version, I normally put the answer in red. So when you see something in red, it is generally my answer. You notice this piece is in red because it could be the answer, but I recognize that I can go further. Take a minute to look to see how it is that I went further here, and then let me know if you see it.
You found the 8th, yes?
Very good.
I had done the thing, sir, but where I messed up, I did 12x instead of 12x squared. So that's where I
Gotcha.
messed up. Hence why I didn't understand how you got the 2x cubed.
Got you. Right. So one of the things that we're looking at is when you're factorizing something like this, and you may say, okay, then, sir, can I leave my answer here? If you were to leave the answer like that, you may be penalized a mark because we are expecting it to go all the way down to the simplest term. That's all a part of the package. So what you need to do is to look at the coefficients. You also need to look at the powers. The coefficient will tell me the highest common factor, which is the same thing as TK spoke about the HCF. And the term, the variable, raised to the power, will tell me what it is that I can take out at a maximum. At a maximum. Look at x to the 5th and x to the 2nd power. What is the maximum worth of x I can take out?
X to the 2nd power, sir.
X to the 2nd power, right? Hint, subtract the smaller, and I subtract, I'm supposed to say no. You can factor out the smaller of the two. This is not subtract. I must have been sleeping. It's going to be a factor, the smaller of the two. You recognize that x squared is smaller than x to the 5th?
Yes, sir.
Yes, sir.
Always factor out the smaller of the two. So you're going to factor the smaller of the two. Am I clear there now? Are you okay? Do you understand better now what to do?
Yes, sir.
Yes, sir.
All right, there you go. I have another question there for you. Y is equals to 2x plus 1 times x squared minus 1. Just one question and then I'll leave you. Will I at any point in time apply the power rule?
No, sir, because it's
No,
Why?
sir.
one. Okay. In indices, this one
Yeah, in the index or power or exponent
is one.
is 1 for both of them. I don't have anything raised to anything greater than 1. Very good. All right, on the mark, get set, go.
Sent a message, sir.
Okay, all right, so okay. Rayton, I big up yourself. I'm trying to figure out what it is that you've done, TK.
Sir,
Yo.
question.
Absolutely, sir.
At any time, can you use more than one rule for a question?
Sir.
Yeah, man, can use no, but yeah, man. That we not reach this yet though. We not give them the
Sir,
complex
where you get the plus? Where you get the plus between the two of them? The rule. The rule. Never mind. It's the rule.
Sir, may I hear you, sir?
Yeah, man, you can. But me not reach
Okay.
them me not reach them the gymnastics yet. Yeah, me try get up to that point. But yes, the answer is yes. Let's go to this one. I don't want anybody to write. I want you all to look at it because I'm a little concerned now that we're not getting this fully. And this is just a product rule, and I want to mix them up because I want today to go into the what do you call it? The past paper. So you have a product 2x plus 1 times x squared minus 1. What we're going to be doing is the first, the second. The first and the second. So it's the first times the differentiation of the second. When I differentiate the second, it's going to be x squared minus 1. So when I differentiate the second, it's not a power. So the differential of the second is going to be 2x. True or false?
True,
Do you
sir.
agree that the,
To be honest,
Come on.
seeing that now.
You don't see it?
Seeing it now.
Oh, you've seen it? No. Okay, and that's fine. I'm happy that you've seen it. So it's the first times the differentiation of the second, then plus. Oh, so someone was asking who got the plus in the middle. Come. Remember, it's the first times the differentiation of the second plus the second times the differentiation of the first.
Question, sir.
You.
So it's only the x only disappears when it doesn't have an exponent, right?
Very good.
Okay.
Well, let me
When
take
it
a
is
bit away.
1.
Then the exponent is 1. Right. I
Yeah,
understand what
that's what I
you're
mean.
saying, but the correct way is when it is 1. Very good, TK. So remember, it's the first times the differentiation of the second plus the second times the differentiation of the first. So let's go again with it. So in my blue is just the differentiation. So let's go again. All of you look at it. What's my friend name? Chrissy, we not hear from you. We don't know what's going on with you. Logan is here. We not hear from Logan either.
I'm here, sir, but it's just because I'm completely lost on this topic. So lost that if I ask question, I might hold you back.
No,
Very
no,
good.
I'm Chrissy. I dare say you're wrong. Do me a favor. I want when I go to church and I throw my tithes, Father God is pleased with me. That the school are paying me for. The Ministry of Education is paying me for that very purpose. No, stop me and ask me the question. That me get paper. I want to feel like me I work for the money. No, man. No.
Sir, it's church ago, sir.
Webster Memorial. Yes, them are. Go on.
Sir, all right. Sir, I understand how you got the 2x plus 1 to equal to the 2x. But
Hey,
for the second,
hey. No, Demo. You said 2x plus 1 to be equal to the 2x. I don't have 2x plus 1 equal to 2x at all.
no. I mean to factorize it and get the the 2x. Is that the correct term I'm supposed to say?
No. Hold on. Terminology is wrong. Come, let's
Yeah, the
fix that.
terminology wrong.
Yeah.
What should terminology
Tell teacher where you are. Where are you? Right here, sir?
Yeah, right there, so sir.
Yeah,
But the part,
tell me what I said.
the 2x plus 1 and the bracket 2x, and I know we'll get there, but the x squared minus the 1 part, it catch me.
All right, I'm coming back to there. All right. Atara, how you stay? You understanding?
The only thing I'll ask, sir, because I think I've realized what I was doing. They can make us do one more question.
Oh,
Like this.
absolutely. And guess what? When I get this tonight, because come next class, God's willing, this is November. And oh Lord, I spent quite a bit of time on some of the other topics because I really wanted you to get it. I kind of feel comfortable that you get it, but there are other topics that we need to go through, right? Yeah. Ataro?
Yes, sir. I understand this one so far.
Okay, good. There was someone else in the call. All right, let's go. The more I want you to look particularly, please. So it's the first and the second. The product rule says the first times the differentiation of the second plus the second times the differentiation of first. So watch this. This times the differentiation of this. Then again, plus this times the differentiation of that. So I'm like crisscrossing. The one with the other, and then do the other with the first. So it's the first times the differentiation of the second plus the second, and then go back to the differentiation of the first. So watch it. The first, boom, I write it back, 2x plus 1. Times the differentiation of the second, I'm differentiating this. When I differentiate the second, I'm going to get 2x. Plus the second, plus x squared plus 1. Oh, sir. So every time you're doing the product rule, you get always have a plus sign in between something? Yes. So it's plus the second times now the differentiation of the first. I'm differentiating the first, this one. When I differentiate the first, I'm going to get 2. Because the differential of a constant is 0. Differential of a constant is 0. I get a 2. Then what I'm doing now is to say 2x times 2x is 4x squared. When I have nothing more for multiply the 2x by, then I have to move to the 1 now. 1 times 2x is 2x. Plus x squared times 2 is 2x squared. I have nothing more for multiply the x squared by, so move on to the other term. Negative 1 times 2 is negative 2. And then now I'm grouping like terms, but sir, my sister, 4x squared and 2x squared are the same family. So we're going to add them. Forget 6x squared, yeah. 2x stands alone, very lonely, so we write it back. So is the negative 2, we write it back. So this could be my answer. It's in red. But I recognize that there's something common here. There's something common here. And that there's something common here. What is common, sir? 2. So when I factor out 2 from 6x squared, I'm going to get 3x squared. When I factor out 2 from 2x, I'm going to get just x. And if I factor out 2 from negative 2, I'm going to get negative 1. Chrissy, any clearer?
Not really. My problem is, as I say, it was set you back. My problem is I'm not understanding the rules outside of first principles. It's something that I have to go back and practice.
All right, we're going to play a game.
Wait, sir, real quick. Sir, can you hear me?
Loud and clear.
All right. For the blue part again, sir. You said the one gonna turn to 0. So how did x squared turn into 2 again?
Because I'm differentiating x squared. I'm differentiating x squared, so it becomes 2x right here.
So you move over the 2 to where the x is. I mean, in front of the x, you're gonna have like a z. 1. Oh, all right. I get it.
come the more. Look, y is equals to x to the n dy by dx. I'm differentiating. So it'll be this n goes in front, C here, and then I put by the x and I subtract 1 from the power, x to the n minus 1. This rule will take you into calculus 1, calculus 2, calculus 3, and calculus 4. You must know this rule. Y is equal to x to the n. Dy by dx is going to be equal to nx to the n minus 1. The power becomes a coefficient and the power is reduced by 1. The power becomes a coefficient and the power reduced by 1. You know, part of the problem is that you guys are not practicing.
Wait, sir, actually the thing is I understand that part. It's just that I'm not getting how the x squared can equal to the 2.
And if you understand this part the more,
All right,
think of
sir.
this being,
So,
no, hold on. Think of this being x squared the more. What
right,
is the
yes, sir.
value of, in x squared, the n will be how much?
Square 2.
Good. So you can put 2 right there, so.
2 right there.
Good.
You take away the 2 from the 1. You have 2x and 1 right there. So you don't have to mind the 1 because the 1 would just be by itself, right?
Good. So the answer could be then. Not 2x.
2x. So Mike,
Yes.
so
So
it
the
equal to
problem. So it equals to what?
2. We just have to take the 2 alone?
This is a different thing, you know. This 2 is a differential of 2x.
Oh.
X is to the first power. When I subtract 1 from 1, I get 0. So if we write back x to the 0 because x to the 0 equals
2.
So 1.
1.
Right. So we have 2
yeah.
times x to the 0, but x to the 0 is 1, so it's just 2 times 1, which is 2.
Let me see what
Yeah,
media. Media
yeah,
put back the same side on the same side. All right, sir.
No problem. All right. So I just need to correct something. I need to correct something. Let me just change position here. I need to correct something because, ouch. One of the mistakes, the greatest mistakes you can ever make in your life as a student. Let me just do a quick survey. By raising your hands, how many of you will be the first in your household to get a degree? Just raise a hand, your virtual hand. How many of you in your household will get a first degree? Okay, so I don't see any hands raised. So am I to assume that everybody in your household already have a degree?
So I go again with question, sir.
How many of you in your household would be the first to earn a Bachelor of Science?
Oh, well, not me.
All right. I see 2 hands. All right. Can I appreciate those 2 hands? All right. Thank you. So I can then assume that everybody else and their family. Okay, Dujan, I'm seeing that hand and I appreciate it. You can lower your hands now, guys. One of the things I always say now, guys, is never leave one of my classes not understanding something and then saying to yourself, I will go and do it on my own. You're going to be lost, not even lost, but you're going to be lost. Let me also say something to you. if ever you think that I'm moving fast, the calculus 1 syllabus is very long. It's very long. Almost, let me not say unrealistic, because we have been teaching it for some time now, and somehow I'm able to cover it. Somehow every year I teach a course, run about this time, I'm somehow at the same place, because there are some concepts that, you know, the truth is, moving from discrete math and algebra and prob and stats to jump into calculus 1 is too big a jump. It is way too big a jump.
Agreed.
Oh, somebody agreed. Oh yeah, it's
Yes,
big.
I
That's
feel like
I agree as well.
yeah, man, that's the first.
Province did not prepare me for this.
Yeah. It's a reality, and I have said it.
They should have
It-
just pre-cal
They sh-
before.
you should have gotten some pre to the calculus. All
Yeah.
right. Now, so I have taught it. I've been teaching for some time now. My first year in teaching this course, I was very frustrated, because I'm saying to myself, but these are bachelor students, I'm supposed to know the stuff. And then when I looked at the stuff, I said, but hold on a minute. What them do before really not prepare them. So that's why I'm where I'm at. Because I have to be very mindful. And you see, it comes back to what I was doing at the start of it. At the start of the class, I was giving you connections because I want you to recognize what was going on. Why? Because I know the preparation was absent. Now that we've moved past that, I'm saying to you, we are here and we have to catch the something to move on. I don't want any of you, Chrisan and others, to leave my session not understanding something and think that you're going to go and do it on your own. You're not going to get it on your own. I'm going to tell you, you may get some things, but the way I explain it, you're not going to see it. That you say, oh, Rockstone, not true, sir, I see it now. Let me tell you what is also true. I build on information. And if I had come to class tonight to say, okay, guys, we went through the product rule, quotient rule, chain rule, and the power rule, we are going to look at some of the applications. Because what I really want to move now to, is application. I should be moving into application tonight. And then I said to myself, you know what is true? We never have no class the last time. Come there to test. And when I said to you that I wanted to teach that last hour, that teaching was what I'm doing now was the reinforcement, so that today I could look at the application. That's why I planned it out. Hear me out now. If you allow the calculus 1 to run away, leave you, I'm going to tell you the honest truth. There is no way you can catch me. You think when I go to school and boy give me jump in a race, them can't pass me? Can't pass me, man. Once me get jumped, can't pass me. And I'm saying to you, if you let me get too far ahead of you, you are not going to be able to recover. Let me tell you what happens when you don't recover. You cannot do calculus 2. Let me tell you what happens to you. You will have to be at the mercy to see if calculus 1 is going to be offered in the summer, where you can do over calculus 1 if you have a fast track class. Or you have to now carry calculus 1 into your 4th year while you're carrying your other courses in order to finish within the 2 years. So when I'm having calculus 1 with the other group next year, God's willing, you're going to be in a class. So you have to go juggle between the two of them. Something is going to give. And if you survive the 2 courses, them juggling, you will have calculus 2 to juggle again. We don't want the juggling business. We want to get it once and for all. We don't want to face again for calculus 1, that is. We want to meet with them again at calculus 2 time. If it is that I'm your calculus 2 teacher. Right?
Hey,
So
sir,
please.
don't do that now, sir. No bother with that, sir. Okay.
Big them
No bother with that,
teacher.
sir.
And no
Beg them to
promises.
interview for it.
Yeah, no promises. But let's go. I am gonna go through this one more time. Chrissy, I want you to come to the front of the class. And anybody, it's not Christian alone, you know. I can talk to Chrissy because I know how Chrissy was active in the class. And once when I hear the activity, they say, Chrissy get one last lick where she just stay stuck. Nobody now pull her. All right, come, Chrissy. And this is a family. Don't feel no we are calling it all Chrissy because this is our little family, and I really want all of you to pull up. So if Rajay not pulling his weight, I'm gonna call Rajay also. Right? So let's go. Let us go. Where do I want to go now, Lord? I am going to go to a place that speaks of the product rule. I think I'm going to start right here. Okay, so I want all of you to use this as an opportunity, as a quick review. One last thing before I continue. Lakana, you sent out the message to me, Papa? Getting that survey out? Because right
Sir,
about now,
I sent you an email. Most of the
Jesus.
persons agreed to Wednesday.
Oh, Lakana, I really miss that. But you sent an email today, yesterday?
Today, sir. Because I totally forgot about it, sir.
Oh, okay. Because guess what? I know I make a point of my duty to check my emails, and I didn't see it at all. That's why I was saying, Lord have mercy. But if you sent it today, I was in meeting from 10 o'clock to 3 o'clock today. So I really
Okay,
didn't
sir.
have.
Most persons voted for Wednesday, sir.
And you know what? Wednesday is not a bad day for me.
Okay.
Yeah, really is not a bad day. So based on where I'm at just now, more than likely it's not tomorrow because we still have a rainy something, right? But on Friday of this week, God's willing, we're going to be making plans for Wednesday of next week, God's willing. All right. So let's go.
Okay.
Thank you for that. Yeah, thank you for that.
Sir.
Papa. Let's on.
Sir,
Yeah, Papa.
any updates regarding Edicasoft?
Yes, but let me just get through this and then I'll give you the update.
All right, sir.
Afterwards, yeah. I'm promised for pretty soon. So let me I had a conversation. Yeah, I had a conversation with the powers that may be yesterday, not yesterday, like Monday. When was Monday? Yesterday. All right, let's go. So the product rule says the first times the differential of the second plus the second times the differential of the first. The first times the differential of the second plus the second times the differential of the first. If you remember that, you shall be good to go. It's the first times the differential of the second plus the second times the differential of the first. Oh, then sir, you won't give us a question, then we're going to have 3 something multiplied by something. No. What am I going to give that for? So I'm not going to give you 2x plus 1 times 3x plus 1 times 4x plus 1. But why? And even if we get to those, the first thing I was said to do is to go ahead and distribute 2 of them and combine 2 of them to give 1. All right? But let's go. So this suggests that you have 2 terms, the first term and a second term. See it right here, so a first term and a second term. So right now, and I'm going to say it again, it's not that you can't get 3 terms, you know. But if you're going to get 3 terms, and to use a product rule, we have to combine 2 of the terms. So we can reduce it to 2 terms. Watch me. The first thing that I'm going to do is to call my first term. Which of them I'm naming my first term? I'm going to call this one the first term. So I'm going to put first up top here, so. And the one I'm going to put second. So dy by dx, the rate of change of y with respect to x, when you see this, you know that you're differentiating. It's the first. Boom. I write it back. Anytime it says first, I write it back. Anytime it says second, I write it back. When we say differentiate, we differentiate. It's the first, write it back. Times the differential of the second, it means we have to go differentiate a piece here now. But I know it's not the power rule because the power here is raised to 1. Exactamente. When I differentiate -3, the differential of a constant is equal to 0. Yesterday, today, and forever. When I differentiate a constant, I get 0. I can't get anything else. But when I differentiate 5x, I will get 5 right here. So plus, remember, and that's why I put the plus in the upper caps, you will forever have a plus sign in betwixt the numbers or the terms when you are using the product rule. See it right here, so can't change, it's constant. So it's plus the second when we call first and second, we write them back. Plus the second, we write back 5x minus 3. See it right here, so. Then differentiate the first. It means I forgot to differentiate that piece here, so the 2x squared. Now work with me. Y is equals to x to the n. dy by dx is equals to n. X to the n minus 1. That's the rule. So watch this. 2 times 2 is 4. I'm going to subtract 1 from 2. I'm going to left with 1. X to the first. Do I have to write x to the first? No. We can just write x. So when I differentiate 2x squared, I'm going to get 4x. What is in blue is the end of the differentiation. If this were a 3 marker, you go on 2 marks. I give you 1 mark to fix it up nicely. Watch me. 2x squared times 5 is 10x squared. Watch me. 5x times 4x is going to be 20x squared. See it right there, so. Watch me again. Negative 3 times 4x is a negative 12. See it here, so. Then when I look at them something here, I recognize that the one year and the 1 year are brother and sister. The other one I want cousin. Sir, how you know? Because the 1 year is just x. But the 1 year is x squared and the 1 year x squared are same mother and same father. 10 plus 20 are 30. See x squared here, so, and see x squared here, so, we put by the x squared right here, so. And because the 1 year cousin and the cousin and have no other cousin, we carry it back. We carry back the cousin. It is in red. It means this could be the answer. But me look close upon it and recognize, say the cousin you saw and them two you saw will combine to give 1. We related, we in the same house. We can share the same thing. We recognize there's something common right here, so, and something common right here, so. So what is common? 6. 6 is a factor of 12. 6 is a factor of 30. We take out the 6. I recognize, yo, something else common. I'm a father, brother, Pitney. So them have the same last name. X squared and X. One name Taxter and one name Tax. You have the R there. So this is Taxter and this is Tax. So we're going to take out the tax, which is the X. What is left? Another X. When I work this now, I recognize that 6x times 5x is 30x squared. And 6x times negative 2 is negative 12x. Me can't go no further with this. So I'm going to press pause on it and call it my final answer. I too am now pressing pause. Is there any question or comment?
No questions on my side, sir. I just want to try it again on the example 4 to make sure I register. So I'm following along with what you're saying, but I want to do it myself just to make sure my brain get it.
No problem. What say the rest of you?
I'm good.
I'm on the same boat as Tika, sir.
Okay. Chrissy, how you stay now? Cash?
It's
Yeah.
better, but I'm having a issue correlating the formula to what is done. So what is done, understanding clearly when it comes to differentiate, and then we'll break it down thereafter. But I think I need to visually see the formula and how you input it into the question.
Okay. Tajay, wait, you're saying something, Papa?
Yes, sir. I was just commenting that it's perfect. You're good at what you do, sir. Good at teaching. So
Thank you, sir. Thank you.
yeah.
Appreciate it. Appreciate it. Dijon, how you stay?
Good so far, sir.
Nice, Papa. Evan, how you stay? All right, Evan, not here. Kenneth, how you stay?
Yes, sir. So far, so good.
Good job. All right. I think I know that Raji is following. I know Rayton is following because Rayton got the answer correct. But let me not assume. Raji, you following?
Yes, sir, right behind you.
All right, good. Rayton, I know you had gotten the last question correctly, but let me not take it for granted. You're following what I just did a while ago, right, Papa?
Yes, sir, I'm good so far.
Good job. Shane, how you stay?
Good, sir.
Nice. All right. I know I didn't call everybody. I never called Kyle. I never called Kaim. Hey, Kaim, how you stay?
Sir, I'm catching up.
Hey, boy, if I look in any, see, I go back with that two before, you know. I go walk with that two before for you.
Something stronger for you, man.
Sir, I'll be fine. I'll be fine. I'll be fine.
Make sure, Pops. Make sure. All right.
Yes, sir.
All right. So now, I hear Sir T, but for the sake of getting Prissy up to this thing, me can't just get her one planting tart and say, yo, all this stage, she's gonna say, boy, sir, I want another planting tart. So let's go. I want all of us to look at this. This was a question that we started off with today. I'm gonna go through this one again. And then possibly with us, well, not possibly, I'm just gonna go through the quotient rule. I want to make sure that we finish off all the rules, and then we just hit the past paper like a flood. Let's go. Work with me again. You know what I prefer? If at this point in time, nobody writes, you will get an opportunity to write. If I'm really in a good mood, I'll send this off to you, like I normally do. I just want to look to see what is happening. Keep a pencil in at hand. If you have a question, write it down. If you see something you never see before, jot it down. Ask me the questions. Let's go. Numero uno. No, numero dos. Number two. Y is equal to 4x cubed times x cubed minus 3. I'm looking at it. I'm looking at the stuff. I'm looking at it and I'm saying, okay, fine. I need to decide which rule I'm going to use. Because the question not going to say, by using the power rule or by using the quotient rule. No. You got to decide which ones to use, which one or ones to use. Was it Lekana who asked if I could use multiple rules in the something? And I said, yeah, man, you dropped one. Yes, you can get one with multiple rules. But I don't really figure that one yet. Because I want to make sure that you understand the rules. Let's go. So I'm looking at it, and there are things that are going through my head and say, okay, you know what is true? This 4x cubed is being multiplied by x cubed minus 3. Well, you know that because when you see the parentheses, them say normally brackets is multiplication because brackets is just separating some terms that have something in common. Oh, so you're saying that the 4x cubed is common to the x cubed and the negative 3? Yeah. All right, see it, sir. That means the product rule, sir. Thank you for seeing that. What does the product rule state? It's the first times the differentiation of the second plus the second times the differentiation of the first. Let me say that one more time. It's the first times the differentiation of the second plus the second times the differentiation of the first. When I call it, I write it back. The first, boom, I write it back, 4x cubed, times the differentiation of the second. You see my brackets here again? Once my brackets, it means it's multiplication. the differential of the second. Now we have two terms inside of this one term. I have one class plus one class, but I have how many students here now? I have 17 students, not 7, because when I log in 2 times, I have 16 students in the class. It's one class with 16 bodies. I have one bracket with 2 terms. So I'm differentiating each term. The differential of x cubed is x squared, rubbishness, is 3x squared, because 3 is going to come and multiply this one to give me this 3, and I'm reducing the power by 1. So 3 minus 1 is going to be 2. So we're going to have x squared left. So I'm going to have 3x squared. But sir, why you close the parenthesis and don't finish? Very good question. Let's go now. When I differentiate -3, oops, it's a constant. Why is it a constant, sir? Because I am not seeing, that is not there, I am not seeing an x term. But sir, you did say an x term is there. Yeah, 1x to the 0. Oh, yes, sir, because anything raised to the power 0 is 1. So if I put x to the 0, it's 1. Yeah. And when you have the 0 and multiply by anything, you get 0. Oh, yes, sir. That's why it's a constant. And that's why when I differentiate a constant, I get 0. So I'm going to close my parenthesis. Sir, why is the sign a plus sign? Couldn't we have a minus or a multiplication or division sign? No, because the rule says the first times the differential of the second plus the second. See, I call the second, so I'm going to write back the second. I'm not changing anything. So the second is x cubed minus 3. See here, so boom, x cubed minus 3. I'm not changing it. Then no, I need to multiply that by the differential of the first. My first is 4x cubed. When I differentiate 4x cubed, watch this, Demoy. 3 times 4 is 12, and I reduce this by 1, 12x squared. See that, so 12x squared. In this blue line, my differentiation ends. All that there needs to be done is algebra. I need to fix it up. I need to put on some clothes on it. And that's exactly what I'm going to be doing. How are you going to do that, sir? I'm going to be distributing. I'm going to get rid of all of the parentheses. I want to see there's something raw. And then I can fix it up and put it together. Watch me. 4x cubed times 3x squared. When I'm multiplying and the bases are the same, I'm going to be adding my powers. They say, all of them because something here, you know, me and go school teacher name I give me, you know. Me put them because something here so they can see what me I do when I'm on their own. But part of the problem is I believe that you guys are not revising the work. Me go stop saying it, you know. Because we said it and now look on something. 4x cubed times 3x squared is 12x to the 5th. 4 times 3 is 12. When I multiply x cubed by x squared, because the base here, remember, you know, this is a base, boom, power, boom. Base, boom, power, boom. Once the bases are the same, a and a, I'm going to be adding the indices, or I'm going to add in the exponents, or I'm going to be adding the power. M plus n. See the base here? That x here, and what here? The rain now stop tonight. I have this x and this x, the same base. So I'm going to be adding the powers. 3 plus 2 is 5. And then I'm going to put my plus sign here. And now I need to distribute this over this. Watch me. X cubed times 12x squared is going to be 12x to the 5th. Sir, where you get that? There is an imaginary 1 right in front of this x, and 1 times 12 is 12. See the 12 here, so? But x to the 3rd times x to the 2nd is going to be x to the 5th. But sir, we can do the question and get to the same something? Of course. But we stop you. Next, x cubed. No, not this one, because I use this one to multiply this one already. So I have to move to the next one. -3 times 12x squared is -36x squared. When I look at this now, I recognize, you know what? The one year rent yam and the 1 year rent yam, we can combine them and get the same rent yam. The 1 year yellow yam. So this is 12x to the 5th plus 12x to the 5th. I can combine these to give me 24x to the 5th. See it right down here, so. And because this one is a standalone, I just write it back. It is in red. So this is my answer, but I recognize that there is something common between the two terms. there's something common between the two terms, and I am required to simplify my answer. But sir, the question never asks us to simplify. You are supposed to be simplifying your answer. Work with me. What is common between 24 and 36? TK spoke about the highest common factor, or the HCF. Now, the highest common factor of 24 and 36 is 12. It's 12. So, no man, if it really continue, so can't go work tomorrow. Boy. All right, guys, can you hear me? Because I can hardly hear myself. Okay, cool. Let me see if this is at 100. It's at 100. All right, let's go. So the highest common factor is going to be 12. How many times can 12 go into 24? 2 times. See, so? How many times can 12 go into 36? 3 times. Right, so that times I say no. Now, watch this something here. This is a trick. X to the 5th and x squared. Then, sir, how may factor out them something here? The aim and the trick of the game is you are going to factor the smaller of the two every single time. It has to be the smaller of the two, because you can't put a big number into a small number to factorize. And when you factor, it means that you can get a whole number. If you put a bigger number into a smaller number, you can get a decimal. That is not factoring. So therefore, you're going to look for the smaller of the two. Now, guess what? All of this x squared can go into itself because it's a factor of itself. But guess what? All of this x squared can fit into this x to the 5th because this is smaller than that. So I'm taking out my x squared. What do I have left? When I take out x squared out of this, I'm going to have x to the 3rd that is left. See here? Make we check it. When we are multiplying and the bases are the same, I add my powers. 2 plus 3 is 5. Yes, sir, we see. And because we take out all of the x squared there, so that one don't have no x squared left. Question done. Are there any questions of me?
Sir, just one question. Would we be penalized if we distributed the function and then use the chain rule?
So he used a big word a while ago. Let me just translate it. So he's asking, sir, what if I were to multiply 4x cubed by x cubed and then multiply this 4x cubed by -3? Sir, will I be penalized? No. But guess what? You notice here written that I'm just starting product rule right here, so talk truth.
Yes, sir, I understand that. I was just asking for an example.
Yeah, man. Me get you. But I'm only saying this because I don't want anybody to say, oh, I'm not a pacer in the mind, then come and just multiply them, come and know for multiply. No. So I just want to crash that so that somebody don't tune me out. I'm just starting product rule. Well, not just, but because I'm reviewing this stuff now. But this is the start of the product rule. So there's no way I can, there's no way I would start teaching the topic and flinging one power rule something and give you 2x squared times 2x plus 5 to the 2nd power. No, me not do this something yet. I started the power rule. See, it is raised to a power greater than 1. Or not 1, because it could be a number that is less than 1, like a minus something. Right? But Rayton, you don't have to worry, Papa, because at some point in time, Rayton, like the next question, I am going to give you y equals 5x minus 7 to the 3rd power times 2x minus 1 to the 2nd power. How many power rules do we have to do right here?
2, sir.
2 of them. All of 2 of them. So what it is that I'm doing is just taking it in strides. So My answer to you, yes, we can do it. And matter of fact, that is the next question in sequence. So the answer to your question is yes, we can go ahead and distribute it. Like this example number 3, we could go ahead and distribute it because the two of them is raised to the first power. But I am only introducing to you the whole concept of the product rule. So really and truly, the question that is supposed to expect to get in the exam is a question like example 4. So just allow me 2 more minutes to matter of fact, allow me 1 minute to just run through this with you, and then I'll take the 5 minutes that are going to be left to ask you to do example 4 for me. The first, second, product rule. I have 2 set of parentheses. This is multiplied by this. dy by dx is going to be equal to the first, write it back, times the differentiation of the second. When I differentiate a constant, -1, I get 0. When I differentiate x squared, I'm going to get 2x. See the 2x here. I'm using the product rule, so it's going to always be a plus sign in betwixt them, plus the second, x squared minus 1. See it right here. So times the differentiation of the first. When I differentiate a constant, I get 0. When I differentiate 2x, I'm going to get 2. See the 2 right here. So differentiation ends here in blue. I'm simplifying. 2x times 2x is going to be 4x squared. 1 times 2x is 2x. X squared times 2 is another 2x squared. And -1 times 2 is a -2. Is there anything common? Yes, sir. 4x squared and 2x squared, same family, 6x squared. The 2x is a standalone, I write it back. So is a -2, I write it back. It is in red. It means that this could be the answer. However, I recognize that I can simplify it because there's something common between the 6 and the 2 and the 2. The x's are not common. Why? Even though I have an x here and 1 more x here, there is no x here. So I can't factor out a x. So because 2 is common, I'm only going to be taking out the 2. When I take out the 2, what is left? I take out 2 out of 6, I have 3 left. But it's not just 3, it's going to be 3x squared. I take out a 2 from x to x, I'm going to have x. And I take a 2 from -2, I'm going to have -1. Questions? Numero 4. Number 4, come. I want you to make a quick and fast attempt on this, please. Quick and fast. You have 5 minutes. You have 4 minutes, actually. I'll use a 1 minute to go through. Quick and fast. On the mark, get set, go. All right. I'm seeing no response in there. Of an answer. So I'm going to ask, there's no 7. Anybody get anywhere close to the answer?
Yes, sir. Give me 5 seconds. I'm trying to type it.
Good job. No, you want to tell me? Tell me, let me see something if you're on the right track. But this may be a lot to type.
Sir, as in the final answer?
Yes, Pops.
So 50x squared minus 78x plus 33.
Anybody
That was
else?
all correct. Yeah.
I think you have done quite a bit of expansion there. That's why. Anybody else? All right, I can make you 2 minutes. What is wrong here? Okay. So, Rachel asked a question earlier. You see how this answer looks? This answer has 3 terms. 1, 2, 3 terms. So there was no way I could start a question like this without even going through the foundation stuff. All right, so this is really complex, so don't worry about it. If you don't get it, it's not a problem. I'm going to send this question off to you tonight, and you can look at it for Friday, God's willing. Let me just go through this very quickly with you. I know you have a class, and so do I. It's the first and the second. The first and the second. It's a first C so times the differentiation of the second, but you recognize that the second now is a power. So we have to be very careful. So this 2 is going to be multiplied by this second term, C so. I'm going to reduce the term in the parentheses by 1. So we have 2x minus 1 raised to the first power now, C so. 2x minus 1 raised to the first power. And then I now have to differentiate what is inside the parentheses. And when I differentiate inside the parentheses, I'm going to have a 2, which is this times 2. Remember, this dot means multiplication, times 2. Right? So when it is a power rule, you have an extra step to take by differentiating what is inside the parentheses. So it's going to be 2, boom, times 2x minus 1, 2x minus 1, to the first power, and then you have the times by the differential of the inside here, which is going to be 2. Then plus the second, plus this 2x minus 1 squared, see here so, 2x minus 1 squared. And then you are going to be now multiplying it by the differential of the first. Watch this. This 3 is going to be multiplied in front to give it this, see here so. And then I'm going to reduce this 5x minus 7 by 1. So it becomes 5x minus 7 to the second power, see here, 5x minus 7 to the second power. But then now I have to go inside here and multiply by the differential of the 5x minus 7, which is going to be 5. And this is how I get the 5 here. So I finish it off here, right here. So what I'm doing here now is just fixing it up. This 2 times this 2 gives me 4. So I put the 4 right here, so, and then leave the bracket ones afterwards. 5x minus 7 to the third, and 2x minus 1 to the first, right here. So then I'm going to do the same thing to the second term. I'm going to have a 3 and a 5 floating. So to say, no, 3 times 5 is 15. So I put the 15 right here. And then I'm going to have this 2x minus 1 to the second power. See it right here. So boom. And this 5x minus 7 to the second power right here. So bam. And then now, when I look at these terms, 2 terms, you know, term 1 has 3 terms and term 2 has 3 terms. I look to see if there's anything common between 4 and 15, and the answer is no. So I leave it alone. Then I look to see if there's anything common between 5x minus 7 to the third and 5x minus 7 to the second. What is common?
5x.
5x minus
finish it out. 5x what?
To the second, sir. So
To
5
the
was
second. Why?
7
Why
to
is it to the second, Rayton? Because I take out what?
the smallest
The
exponent.
smaller of the two. Very good. So I recognize that inside of this, 5x minus 7 to the second, 5x minus 7 to the third, I have to take out the smaller of the two. So I've taken out all of 5x minus 7 to the second power. See, so boom, 5x minus 7 to the second power. And when I look at this now, 2x minus 1 to the first, and I look over here, I say 2x minus 1 to the second. So I'm going to factor out 2x minus 1, but I have to take out the smaller of the two, which is a 2x minus 1 to the first. So this is the first stage of my factorization. Then I'm going to check to see what is left. Remember, I never took anything from this 4, so I'm going to write back the 4. Remember now that I have 5x minus 7 to the second, but I have 5x minus 7 to the third up here. How many of the 5x minus 7 missing?
2, sir.
The 1.
Yes, sir. That's one.
One,
It's
sir.
5x
1.
minus.
So, right. So I'm going to put back this 1, 5x minus 7. So it's 5x minus 7 to the first power, because that is only 1 missing. But, sir, what about the 2x minus 1? You notice that this 2x minus 1 is the same thing as this 2x minus 1? So there's nothing more missing. And then I go to the other term. I didn't take out anything here, so the 15 has to go back. When I look at this 5x minus 7 to the second, it's the same 5x minus 7 to the second here, so I don't have nothing more. Nothing of the 5x minus 7 is missing. But when I look at the 2x minus 1, I recognize that I have an extra 2x minus 1 here. So I have to account for that extra 2x minus 1 right here. So watch this. You notice that this is the same term as this, is the same term as this. You see, once I catch out here, so the first set of something, this now go change, this now go change, this now go change. Watch this too. You see this 2x minus 1? Boom. 2x minus 1. Boom. 2x minus, it now change. The only thing that is going to change thereafter is what is now inside of my square brackets. 4 times 5x is going to be 20x. 4 times 7, negative 7, that is going to be negative 28. 15 times 2x is going to be 30x. And 15 times negative 1 is negative 15. Never write back them to something here. See it right here, so? This never work. 20x plus 30x is 50x. Negative 28 minus 15 is negative 43. This can't go no further because there's nothing common here that is common there. Answer. I know that was a lot. Don't worry about it. I'm going to go to my other class now. So I'm encouraging you to go to the other class. I'm going to send off this thing. When I get a little break in the other class, I'm going to see if I can send it off to Lecana so that he can send it off to you guys. Students, a math a day takes the failure away. A math a day takes the failure away. Have a good one. Talk to you.
All right, sir. Thank you.
All right, sir. Good night.
Sir? I'm done.